our agenda.
Is everyone admitted, Mike? And should I start or should I give a few more minutes?
Yeah, people are still trickling in, but I think you can go ahead and get started, Cindy. Thanks.
Okay. Hi, everybody. Thank you for logging into our virtual forum. We're very much looking forward to being back in the boardroom with you all, but unfortunately, it wasn't going to happen this month with rising COVID numbers. I am the Senior Director of Data Science at Sandag, for those who don't know me. We went through a slight reorganization in February. And so I've been at Sandag since 1992, almost as long as Mike Flandra has. I think we're pretty close. Yeah, so I have transportation modeling under me, estimates and forecast. We have our data science groups with the economist, as well as criminal justice research, applied research that compiles all the data that goes into our transportation models. And we're working closely with planning. So I'm very excited to be here and have this opportunity to do this introduction for you. We are recording this, so just be aware of that, please. Mike gave me some things he just wanted to have me share with you as we do this introduction. We have had some staffing changes at the agency. A few of our staff have moved on or retired. Both Pat Landrum and Tom King have retired. Nico Beltran, who some of you may have known, moved to DC and is working as with the Federal Reserve, I believe now. Jaylen's son also left us, but we have some new staff that we're excited to introduce to you. Secundo Ariano and Eric Wang are two new modelers who are joined our team since our last modeling forum. Ing, who hopefully many of you know, is now a principal over our application, the running of the model. We also have Joaquin and Jeff were promoted up within our team. And I'm sure many of you know, everybody should know Woo-sung. Dr. Woo-sung is now a director level position over both of the modeling teams and will be helping us to build those teams back on. We'll have some other staff who are coming on in the next few months. I'm sure I forgot somebody. Oh, we also have Anne, who came from another part of our agency over working in our ETL process, who's going to be working on the modeling team as well. And we had one other staff lead, Enrique. So a lot of staffing changes going on. Mike wanted to share some of the board direction. Some of you may have seen, I believe the last forum was before we had the regional plan was accepted by our board of directors in December. We got immediate direction from the board at that time to look at what would be the impact on our model if the road user charges were removed. And we are going to be going back with some preliminary modeling results with that in July. The planning department is going to be sharing that and asking for some further direction in September. We also are working very hard, and I'm sure Mike is going to be sharing this as I see on the agenda of where we are with the release of the 14.3.0 and what that looks like and what the timing is. So that will also be coming up. If everybody, just some housekeeping issues, if everybody could keep their mics on mute, just so we don't get any disturbance while our people are presenting, that would be great. If you have any questions, the chat box can be used to put those out there. Joaquin will be reading the questions during the question and answer part of the agenda. And Mike, did I miss anything?
I think you pretty much covered everything. The only other thing we would have told people are where the elevators and the bathrooms are.
Okay. Well, thank you very much, everybody, for joining. I'm going to go look at and see who's on the participant list. I look forward to getting the chance to meet you in person at some point soon. And I'm excited to see everything that the modeling team is going to be sharing with you all and to see some of the questions and discussion we have. So I'll turn that over to the big data evaluation so you can see what we're doing with big data. And that will be Joe Flood.
Right. Hi, everyone. My name's Joe Flood. I'm an associate researcher and modeler in the travel model or transportation model group at Sandag. And I'm going to go over, we did an evaluation of some big data sources. We'll mostly be covering Replica, which we are in the, which is a big data provider whose data we are in the process of purchasing. So first, I'll briefly discuss some of the objectives of our analysis of the big data. And then I will move on to, I'll go over some of the synthetic population and travel data from Replica's data. And then after that, Replica also provides data on traffic. So Jeff Yen's going to talk about that. And then after that, Susan Shu is going to talk about another big data source that we've looked at, Teralyx. And then finally, Jeff Yen will give some concluding remarks. So without further ado, we'll move on to the objectives. So the Replica data, we wanted to compare it with some observed data sources that we have, as well as other big data sources, along with results from our activity-based model that's pretty well validated. And so we wanted to, identify some recommended use cases of the data, not just for modeling, but potential uses for, general planning outside of modeling. There's plenty of applications there. And then also, our agency, we have this whole plan to buy big data. So we want to find where the holes in the data sources are, and should we go with single or multiple big data vendors. And then right here, there's a cartoon from Dilbert. The boss from Dilbert, I forget his name off the top of my head, but he's saying, with pointing to big data and saying using it is the hardest part. And that's absolutely true. You get all this data and it's kind of what do we do with it? So moving on. And so the big data is, we don't just kind of get the transportation from the big data itself, or at least the provider doesn't. So they basically get, here's kind of a couple sentences from another provider's ebook. And so basically what they get, are just kind of latitude and longitude coordinates at various times and a device ID. And then they have to develop algorithms in order to kind of derive travel information from that. And so it's these algorithms, they derive, various travel attributes. They often kind of try to estimate what the trip mode is, trip purpose, all the various different attributes of the travel. And then often these can be very similar to the transportation models that we use. It's like I said before, the providers are just given latitude and longitude coordinates at different times. So you have to create all these complicated algorithms to actually get something useful from that. And one thing that's important to note is that this big data, it is not ground truth. Often providers will try to kind of present it as such, but we need to evaluate it to make sure it's, what we're getting is worth what we're paying. Then moving on. Next slide, please. Thank you. And so this isn't the first time we've looked at big data at Sandag. We've used PEMS data for model validation. INRIX is a provider. They give a lot of speed data. It's one thing they do. So we've validated our model based on INRIX speeds. We've used Streetlight. That's another provider. Use them for kind of special generators. The casinos and places like SeaWorld or Legoland. We've used AirSage data to look at military travel. We've got all these, a lot of military bases here in San Diego County. And then also, which Susan will talk about a little bit, we did use some Teralyx data. And we've actually had kind of a mutually beneficial partnership with Replica. So they kind of gave us an initial data set and we looked through it, kind of analyzed it, compared it to our model outputs. And we did find some differences that were pretty concerning to us. So we kind of gave Replica some feedback and they improved their algorithms, which then, would benefit all of their clients. And after the updates, things aligned better with our ABM results. And we also, I'm not personally on this team, but some of the other modelers are we're also evaluating some data from Streetlight as well. So moving on to so one thing, like our activity-based model, Replica has a synthetic population, and then they simulate or estimate the travel of that synthetic population. So if you look here on the left, so these are the MGRAs where households within our synthetic population that we use in the ABM, that's where people live. And so before Replica's update, this is where people were living there. If you look, they kind of had people living everywhere, including a lot of sort of like state parks and all that stuff in the eastern part of the county where people don't actually live. But then after we gave them some feedback, they updated their algorithms, and they're now kind of the distribution of where people are living better matches our synthetic population, which is good to see. And then I'll go over a few of the characteristics of the synthetic population that are important for modeling transportation. So here we have the household income distribution. That's an important one for modeling travel. It's everyone knows that income plays a huge role in people's transportation behavior, and overall the distributions match pretty well. They do have a few households that have a negative income, so that's kind of an interesting result, but overall it's pretty good. Moving on, yes, employment. That's another very crucial one for modeling how people travel, because if you don't have a job, you're not going to travel to work. And in both our data sets and the Replica data set, both before and after the update, they had about half of people had a job. And this is, usually unemployment rates are based on people who are in the job market. This includes everybody. So moving on, we've got auto ownership, another crucial one for modeling transportation, because if you don't have a car, you're probably not going to drive too much. And so this is auto ownership by household. And then for this one, we have compared both to our ABM and our 2016 household survey, and everything matches pretty well. So then we looked at a lot of others and they all matched pretty well. So that was good to see. So now moving on to the actual transportation, the actual travel data. There were some kind of interesting things with the data. For one, they classified their travel modes differently. So within the Replica data set, if you have multiple people within the same car, the driver is given the private auto mode and the passenger or passengers are all given the carpool mode. Now, within both our model and our survey data, if you have multiple people in the same car, then they're all just given the shared ride mode. So I kind of had to make some adjustments to the data to kind of make it more of an apples to apples comparison. And after doing so, the results are on the next slide. The modes match pretty well. If you look before Replica's update, they had a lot more walking trips and a lot fewer carpool trips than after the update that that improved. Walk share is still a little high, but it's way better than it was. And then moving on to trip purpose, we had kind of a similar thing where there were differences in how the trip purposes are defined. For example, within our model, we have an escort purpose. It's things like people taking their kids to school, or just escorting someone somewhere where you normally wouldn't make that trip. Replica didn't have that, so I just kind of proportionally redistributed the escort trips from our ABM outputs, kind of a quick and dirty solution to make it more apples to apples. Replica had an other purpose. I just kind of lumped that in with discretionary, which is something we have in our model. And then based on some correspondence I had with Replica, their purposes are classified based on the land use at locations. And I asked them what the precision on the location-based data was, and they said about 10 to 400 meters, depending on phone settings, and like being in an urban canyon adds some noise to that. So first I'll look at the share of purposes. And if you notice the Replica data, both before and after the update, they have more shopping trips, but fewer like maintenance trips. And going back to the precision, we move on to the next slide. So this is a strip mall that we have in our region. And if you look, there's all these businesses that are very close together that all have different purposes. And then if you look, I added a line here. That's about 10 meters. It's supposed to be on the wall there. So they said at best, we have about 10 meters of precision. So let's say I'm in that laundromat, or I'm actually planning on doing laundry tonight, and my phone pings while I'm there. It could have me in the Chinese restaurant next door, or even the nail salon 2 doors down. So that's that 10 meters. That's kind of the best case scenario of precision. The worst case, they set up to 400 meters. This is a circle with a 400-meter radius centered around our office. So if I was at work and my phone pinged, it could realistically record me as being anywhere in that circle. So given that, the fact that our purpose distribution matches as closely as it does, I think I have it again on the next slide. That has me feeling pretty good about Replica's or purpose distribution. It has me feeling good about their data. So if we move on, yeah, travel distance next. For public transit, that matched pretty well, but for the also for bike and walk modes, there was pretty good match. For auto modes, however, the Replica's trip length was a bit longer than what we had from our model. And I looked, and that was across all purposes. And moving on, that's right. Travel time, however, it's actually kind of sometimes the opposite pattern. So I don't know if it could have to do with the discrepancies and kind of how they're deriving speed from the cell phone pings they get. And then looking at commercial vehicle data, there are some differences in that, some very noticeable differences. One thing too, between the heavy commercial, light commercial, and medium commercial, I don't think I've seen two truck data sets that have defined heavy, medium, and light trucks in the same way. So I guess, or I would guess that there are definitely some differences in definitions there. And then moving on to external travel. So if you look within internal to external, this is the mode share for each of those markets. they have a lot more people carpooling than we do in our model. So that's kind of interesting. And then, and then I guess I'll hand it off to Jeff Yen now to talk about their traffic data. Thanks, everyone.
Hi, everyone. This is Jeff Yen. I'm an associate data scientist working in Wu's team. So I'm going to introduce our big data evaluation result, mostly using replica traffic data. So we evaluate replica traffic data in three purposes. We compare their freeway volume and speed, and also compare transit boardings, and lastly, we compare arterial volume and speed. Next slide, please. So first thing we do is we have a Power BI visualizations that visualize all the statistical indices. So these statistical indices available to three pairs of the comparison. So the first thing is we compare our ABM estimate with the observed PEMS counts, and the second one we evaluate the replica versus the PEMS counts, and lastly we evaluate the replica versus our ABM estimates. So as you can see here, the post-update replica data has a lot improvement in each of the statistical indices. So the R square, when the R square is getting close to 1, meaning the performance is better. The percent root mean square error, smaller is better. So you see the post-update PRMS is about 10% lower. And the slope, when the slope is getting to 1, meaning your model estimate is getting close to the observed or ground truth. So we do see a lot of improvements on the post-update replica. However, when our ABM estimate is still better than the replica estimates. So if you look at the ABM versus PEMS, across different indices. So can you go to the next slide? Yeah, and then so for the freeway volume evaluations, we have some key findings. So the first thing is we found that at the general purpose lane, the replica volume generally follows the trend of the PEMS count and ABM volume. So we were gonna show the Power BI dashboard after this slide. But we do observe some corridors showing the overestimated replica volume or underestimated replica volume. So for example, for the sorry, can you go back to the previous? Yeah. And for the HOV lane volume, since there are some limitation on the replica data itself, so we do observe a significant overestimation, but there's a reason behind that. We will explain later on. Can you go to the next slide? Mike, can you click control and navigate to the dashboard? And can you scroll the x-axis to the right? There's a score bar under the bottom. It's above the order and name columns. Yeah, right. So as you can see here, the black line is the replica volume, and the red one is our observed count, and the green one is our ABM model estimate. You see, generally speaking, the replica volume actually pretty well aligns these two data sets pretty well, but you do see some corridors have a little bit off or above. You can see the gap like this one. The one I observed the most is the SR15 southbound. So if you click on the freeway corridor field, I think it's the second one, the I-15 southbound. Yeah, you can see here a few segments on the I-15 southbound. There's obvious there's underestimation and overestimations, obviously. Yeah, so that's pretty much for the general purpose lane. Mike, can you click on the next tab? It's called Freeway Corridor High HOV. And then turn off the I-15 southbound. Yeah, just click that one off. So here, we saw a lot of significant overestimation on replica HOV volume. It is because in the replica network, it was built based on OpenStreetMap, and which doesn't have the HOV lane or GP lane separate. So that's basically the constraint of the network they have. So what they suggest us to do is we can try using couple trip as a proxy of the HOV volume. So that's the current chart is the proxy that we use the couple trip as a proxy to showing the HOV lane volumes, but it doesn't look really make sense. So after we talked to replica team, they acknowledge that maybe we can just remove the HOV volume because they essentially they don't have HOV volume when they release the first product to us. And Mike, can you go to the last tab? It's called Freeway Corridor. Yeah, that one. So so when we remove the replica volume, so basically we just look at the ABM model volume, ABM HOV volumes compared to our observed HOV counts. What you see is actually our ABM performance is pretty well. It's the reason I shown this is because when we do the internal meeting, someone raised the questions. They wanted to see how well our ABM estimates aligns to the observed counts at the HOV lane. Okay, Mike, can you go back to the slide? And next one. No, this is the dashboard. And next one. And next one. Yes. So in terms of the freeway speed variations, you can see here the pre-update replica speed, you see a very less variation in looks like the post speed to us, and after we give our feedback to them, they adjust their speed to more like a congested speed. So still the black line represent the replica speed, and the green line represent ABM speed. The red line represent the INRIX speed. So here you can see the more like the post-update replica speed is more like the congested speed, more variations, more makes sense right now. And can you go to the next slide? And the last, the third is we compare the transit boardings by total, and then we do observe that after the post-update transit boardings, the replica, the gap between replica and observed boarding is increased about 4% magnitude. But when we compare the transit boardings by mode, which is on the next slide, we do see a lot of improvements when you look at the tables on the bottom, especially in the community rail and rapid bus. These two modes has a smaller gap than our ABM results. And the reason why they have so much improved on this is I think they injected our transit boarding inventory, and also they acquire other boardings data from MTS and NCT on their own. So actually they do have injected multiple data to correct their estimates. Next slide, please. So the last thing is we do the arterial traffic data evaluations. So this one, if you look at the red line, it is our observed arterial count. But I want everyone just to focus on the green line and the blue line, because they are represented for street line arterial volume and also the replica arterial volume, which is in blue. And these two, it is really hard to tell which one is better because we only have very limited data point. But but I want to mention that is neither streetlight or replica, their arterial volume is generally like lower than our ABM estimate, which is in the blue line. Sorry, the ABM estimate, the SPM is in blue line and the replica is in black line. Sorry, I have to correct that. Can you go to the next one? And in terms of speed data, we have some interesting finding because the replica speed is more is aligned the streetlight speed pretty well. So actually, you can see the green line and the black line, they are actually pretty much similar. And due to we don't have the observed arterial speed, so we use our ABM arterial speed as a references. I won't say it's 100% accurate, but it just, you know, we can use it as a baseline to make a comparison. Okay, can you go to the next slide? Yeah, and then I wanted to summarize what we just talked about right now. So in the Freeway volume evaluations, we see the post-update replica showing the statistical evaluation improve. And in the GPM evaluation, they generally follows the patterns of PAMS count and ABM volume. But we do see some volumes are in certain corridor are systematically overestimated or underestimated. And the HOV values are significant overestimate and are not recommended to use. So for the replica speed, the post-update speed is make more sense and it looks like congested speed and it actually aligns with the entering speed well. Next one. And for the transit boardings, we can just focus on the transit boarding by transit mode. We see a lot of improvements after we use the post-update replica boardings, especially in commuter rail and rapid bus, these two modes. But across, in general, for all the modes, they have a lot of improvements in the post-update replica boardings. Next one. So the last thing is in the arterial traffic data, compared to ABM, replica and streetlight arterial volume are generally underestimated. In terms of the speed, the arterial speed, the replica and streetlight speed generally aligns with the ABM. So that's the conclusion that we have right now. Next one. So the Susan Shi will talk about her findings on the Teralytic data.
Hello, everyone. I'm Susan Xu, Associate Transportation Modeler at SANDAG. Today, I'm going to briefly talk about an example of big data that SANDAG had implemented in regional planning report. It's called Teralyx. So for anyone who does not know Teralyx, it is a big data analytics platform that offers insights on human mobility based on cutting-edge data science, machine learning algorithm, and deep technology, capturing billions of signals every day from cell tower and other unique sources. While preparing for analytics in 2021 regional plan, SANDAG purchased third-party data Teralyx metrics, which delivered a dashboard for trips inside San Diego County and the surrounding counties in 2018. This slide shows some key findings comparing the Teralyx data with SANDAG household travel survey and ABM base year outputs. So the first finding, we found that trip rate is calculated to average of 2.4 in Teralyx data. It's much lower than the average trip rate of 4 from both 2016 household travel survey and base year ABM output. We figured out that Teralyx team utilized a minimum trip stop of 30 minutes to count trips. For example, the short trips such as trips to gas station, coffee shop, or laundry, those trips are not counted in Teralyx data. And the second finding is on mode share. There is a lack of information on trip mode and trip occupancy in Teralyx data. And third, for trip purpose, there are only 3 categories of trip purpose in Teralyx data. They are to home, to work, and to other. Work trips are much less than expected from Teralyx data. Possible reasons are data loss due to the anonymization for privacy. Chips are not captured due to the lower cell tower density, and some miscategorize chips to other purpose due to the GPS accuracy issue. So I'm going to introduce two examples of data loss in Teralyx data in the following slide. Next slide. The first example is about data loss due to the anonymization for privacy. This figure shows the trips come to Point Loma on weekdays of May in 2018. We could see the trips in May are much less than trips in other months. There are only 9 trips, and all the 9 trips are to other purpose. And we know in Point Loma, there is nowadays, there must be 2 work trips for sure. So some data loss due to the privacy issue. Next slide. The second example is showing the trips come to Balboa Park, which is very popular place in San Diego. And we can see there are 2 home trips happening along the day. However, there's no home units building in the park. So again, something wrong with the miscategories in trip purpose. Yeah, that's a very brief introduction of the Teralyx data. So I will pass to Jeff for conclusion.
Mike, can you go to the next slide? Yeah, so for conclusions, well, we have 3 main conclusions. So first, big data is not ground truth, so we need proper evaluations. Second, big data are useful for augmenting existing data sources. And third, our agency's big data procurement plan is under these 2 bullet points. So that's pretty much the conclusions that we have. So now Mike Kendra will introduce the mode choice reports.
Well, before we actually move on to the mode choice reports, I just want to remind everybody, if you had any questions, please, at this point in time for that questions for that first presentation, now's the time to put them in your chat. And I'm checking in with Joaquin to see if we have any.
Hi, Mike. We don't have any questions posted in the chat at the moment. Thanks.
Okay. All right, well, we can come back to them if we do get any questions in there, but for the purpose of keeping on our agenda, let's go ahead and move on. This is actually going to be, I think, a shorter presentation today. In fact, there's only 1 slide, and I'm going to give you a quick demonstration. So it was about 2 or 3 months ago, we rolled out jurisdiction-based mode choice reports. And we decided to publish them for the 4 main horizon years that everybody is probably intimately familiar with, because they're the same horizon years that we've published data for in our Traffic Forecast Information Center and our SB 743 VMT screening maps. The report itself is now been ported over to Power BI, but it actually was originally came from the old Service Bureau sub-area reports. And probably one of the more important things to note is that this data set has been peer reviewed, and probably including a couple of external people who are probably in the audience participating. I've left a direct link right into the application here for you. So when you open it, you can get, when you download the slideshow from the website, you can open it. But you'll notice up here at the top, we have links back to TFIC and the 743 VMT maps. And in fact, if you click on either one of those, you should see at the very top of it a link back to now these new mode choice reports. I just wanted to maybe walk you through this really quick, and then we'll I think take some questions and then move on. So notice that this first one is 2016, and as we scroll down, we go to 25, 35, and then 50 at the bottom. You have the ability over here from a drop-down list to choose a jurisdiction that you want to see. So for right now, we have basically the 18 incorporated cities plus the unincorporated county. So if we click on one, you'll notice that the chart actually quickly updates itself, which is very nice. We did, as I mentioned, we had a peer review, and one of the comments that we had in the peer review panel is we should only have to choose this once. And unfortunately, that is a limitation in Power BI. And if any Power BI experts are out there, please contact Jeff or myself or Kundo or any of us really, and give us a tip on how to automate that part. But really the point being is now we can look at Chula Vista, mode choice side by side. In the report itself, we've got now demographics, and if you hover over any of these things, you'll get these little tool tips here. So it'll give you a description of what we're looking at. Demographics, the population and employment, obviously being the biggest drivers. The study area trips then should match what you see over here for the daily mode choice. These are person trips. We've included a set of average trip length metrics, and this was actually also derived back in the old ABM1 Series 13 paradigm when we were working in particular with the city of San Diego. You'll notice there's this vehicular internal capture rate. This is basically the same internal capture rate that's going to be used when we do the Climate Action Plan VMT. So when we disaggregate the VMT for the city of Chula Vista, in this case, we know 40% of every trip that starts in Chula Vista also ends in Chula Vista. Getting back to the PRP itself, we had some comments about wanting additional features. And this little chart here is now one of them where we've added resident person trip length distribution. And there were a couple of other things that were being requested, but I think we've kind of run out of room and how much stuff that we can cram onto these reports. But really, this is what I wanted to do, is just kind of walk through a quick demo, let you know that it's all now linked to the other applications that we have published data for. So it's almost like between these three applications, you can really start to get a very diverse amount of transportation modeling data. And with that, I'm going to go ahead and stop and pause and go back to Joaquin for a minute, see if we can catch up on our questions. It looks like maybe we have some.
Hi, Mike. Yes, we do have a couple of questions. I believe the first question is how large is the expected contract for big data? And I believe that Dr. Sun can provide the answer to that.
Well, thank you, Joaquin, and thanks for the question. Yeah, we're in the process of talking to multi-vendors. Our plan is to purchase a multi-year, multi-vendor big data sources. The reason being that, as good work our staff has done proved that big data are not ground truths, so rather we need to, some data are good for, this part of the work, some data are good for other part of the work. You will kind of want to combine them together, so to form a reliable data set for, not just for ABM, but also for general planning purpose as well, the size of course, we have a budget, right? But the budget is going to vary a little bit year by year. So it's very hard to put a number there, so if in any of interest, we can talk offline about the first year agreement, purchase. That'll be my answer. Does that answer your question, Ed?
I think so. Thank you, Wu. And then we have another question that I was able to answer in the chat, but I'll go ahead and repeat it just for the recording. Did I hear it right? It was mentioned that Teralyx data was used for the RP 2021. Is that right? And if so, which data and how was Teralyx data used for the 2021 Regional Plan and Sustainable Community Strategy? So to be clear, the Teralyx data was not used to estimate or calibrate or develop ABM 2+ or version 14.2.0 or 0.2, excuse me. So it was not used for that, but the Teralyx data was extensively used by our planning and consultant design teams during the new process that the agency wanted to engage in for this past regional plan. So that data product was able to provide a lot of good turnkey visualizations and customizable visualizations that normally would kind of take us maybe a little bit more time to get from the model. But it does, I think, really demonstrate how these different sets of large data definitely do have roles in the agency. And so I think now that these data products are getting a little bit more refined, we're going to try to, really find additional roles or additional data products that we can use in accompaniment. But I believe as we develop ABM3 and Wu and the development team are able to move along with that, we will try to make a note of kind of the data sources and methodologies that those teams are using to develop the model that's going to be used in the next regional plan, which is underway. So as we like to say, it's like painting a bridge. We got to the end last December, and we'll be starting at the beginning here already. So I think that addresses that one. Let's go back to the chat. What TNC data was helped to inform the TNC mode choice in the mode choice dashboards and those data products? So I think, Mike, can you take that one?
Actually, I think Wu was going to answer that one.
Yeah,
Okay.
let me take try to answer this question. So the current ABM model, which is ABM2+, largely are built on two sets of surveys. The majority of it's coming from the 2016-2017 household travel behavior survey. And when we're doing the 5 big move modeling, we quickly realized some of the emerging mode are not in the 2016 survey. So therefore, there is another survey, 2019 survey, with oversampling on TNC data, and that's a joint effort of SANDAG, MTC, and SCAG. So the short answer to your question, Claudia, is that the TNC mode choice is built on top of the 2019 survey.
We have anything else in there, Joaquin?
Yes, there's an additional question about, is the big data going to be available to cities or other stakeholders in the San Diego region? And if there's any cost that, those stakeholders would contribute. I think the answer to that for now is that as we bring in these data products and use them, these data products do have use and dissemination agreements that we have with the vendors. So I believe we're going to look into that. And very similar to, I think, in the way we were able to disseminate some of the Teralyx data, while we wouldn't maybe be able to release the raw data right at this moment, there might be some aggregated data products that would be available. And I believe with the current position of big data kind of at the agency and the agency growing into being able to, I think, process these a lot easier. There are, I think, other possibilities on the table that can definitely be up for discussion in terms of data sharing agreements and things like that. But I think right now, unless maybe Wu or Cindy or maybe even Mike Duncan can maybe chime in, is I don't believe that that's fully turnkey at the moment with us being able to share. But that certainly is not, I think, set permanently for now. I think it's more of us trying to get a handle on the data, what's best for the agency, what's best for the modeling team, and then we'll figure out how best we can widely distribute that and maybe, put it on flyers and drop it over cities in the region for everybody. But if anybody else wants to chime in on that, I'll open the floor.
So Joaquin, let me chime in on that. Okay, so the license, right, of the data vendors varies. I know some vendors, for example, Replica, right, allow multiple government agencies join to put together funding to have a license, so everyone can use it. So I mean that's one option. But other data vendors may have different kind of approach. So that's something I think we need to look into, as Joaquin mentioned. So this is not in our first year data purchase plan, But again, we have a multiple year data purchase plan. So in the coming years, so depends on which data vendor we are going to purchase the data from. We can probably talk to our partner or stakeholders, to discuss our strategies. So.
Thanks, Wu. I think there was one additional question. Are the mode share templates presented by Mike available online? If not, can we access the link? Can you share the link via chat? And I believe Mike Calandra was able to put that link in the chat. So hopefully that is a satisfactory answer to that question. And other than that, I think we're clear for now. If feel free to put more questions in the chat. I might be able to answer them kind of extemporaneously during the presentation in the chat. And if there's a need for further discussion after any other subsequent agenda items, we can definitely discuss them out loud. So thank you.
Joaquin, I just noticed, it looks like we have one hand raised.
Okay, I don't see that on my screen, but if any of the other meeting hosts want to maybe acknowledge that, we can unmute them.
Oh, Brett Caldwell? Brett, you are muted. All right, well, we can come back to Brent if we need. Okay, so let's go ahead and move on. I'm going to actually go ahead and pass it over to Ing to introduce our next agenda item.
Good afternoon, everyone. Yeah, nice to talking to you. So I'm going to talk about the ABM 2+ enhancement, the 14.3.0 release. Sendak used the ABM 2+ 14.2.2 for the 2021 regional plan last year. Since then, Sendak continues to improve and update ABM. The post-2021 RP ABM version 14.3.0 includes bug fix, model updates, as well as input changes. Next slide. The previous slide. Okay. So 14.3.0 includes a cross-border model bug fix and recalibration with passenger crossing by ports of entry by year from the draft 2018 traffic and revenue study. The total border crossings across the ports stay the same, while crossings at Old Mesa East and volumes on State Route 11 are slightly higher compared to those from the ABM 14.2.2. The airport model is updated to use the latest 2019 airport forecast from the San Diego International Airport. Compared to the 2013 airport forecast, the 2019 forecast has much higher employment growth, particularly from 2029 to 2035. The larger projected employments in 2019 forecast result in slightly heavier traffic to and from the airport and slightly larger regional VMT. As part of the Grand Central and Central Mobility Hub studies, we enhanced airport ground access module for the airport transit connection analysis. The default setting of airport transit connection is at the nav wall site, as has been assumed in the 2021 RP. The airport ground access model offers the flexibility of setting a different location of the transit connection. So it's an improvement. We also revised Series 14 land use files due to employment allocation update of a few MGIs. So the most important feature of 14.3.0 is the sub-area enhancement with land use override and TAZ split, a joint effort between SANDAG and ISG. Next slide. There are several versions of the Series 14 regional growth forecast. Data source 17 is based on 2018 Department of Finance projection and used for the 2019 federal RTP. Both the data source versions used for the 2021 RP, which is the DS38 and DS39, and the post RP, which is the DS41 and DS42, have the same region-wide total household and population based upon the 2020 DOF projection. The difference is in the land use employment allocation by MGIA. The base year 2016 data is the same across data source 41 and 42. So next, Mike Quindle and Hannah is going to go over the ABM2+ sub-area enhancement in more detail.
Okay, thanks, Ing. So I know we've taken this this enhancement to this forum a couple of times, and then we've actually seen this chart a couple of times. So here's actually where we are today. Model enhancements are pretty much complete, and we are still doing some application tests literally as we speak. They will definitely all be done by the end of July, if not sooner. But otherwise, I think we've essentially gotten through our entire scope and schedule with our consultant RSG. So getting into a little bit more details about this enhancement, you know, it's really intended to automate and streamline the whole process. And one of the most important things to do that was converting all of the scripting that we had into Python. It's really, I think, streamlined it. That alone has really streamlined it. One of the other things that we are getting back to now is use of a flexible TAZ system. So back in the old 4-step world, we used to have the ability to subdivide a TAZ depending on the underlying MGRA. Now, just to, I guess, go through the acronym soup, TAZ is a traffic analysis zone, and an MGRA is a master geographic reference area, and the latter nests and fills into the TAZs. So if you've got 2 or more underlying MGRAs, that TAZ is subject to be split. It has the possibility to be split. When you do that, you go hand in hand. You also need to update your network to accommodate the new zones with zone connectors. And then we're also going to have to think about now doing a build and a no build scenario. We'll get more into that later. And then finally, the automation of the shadow pricing routine and then some QA/QC input checking has also really enhanced the tool for SANDAG staff to use. So the process is a little bit different, but mostly the same. The MGRA is still the geographic unit for the inputs, so everything will still be at the MGRA level. Nowadays, though, with this new tool, we have the ability to either replace or append your custom land uses. So in the ABM1, when we had the land use override procedure, then it was always just replace. Whatever you put in, that's what you're going to get out. Now this gives the user a little bit more flexibility. And when doing land use scenarios, to be able to provide a true apple-to-apple comparison, when we're doing land use scenarios, we really now are going to feature both build and no build scenarios. And the reason for that is because we're looking at implementing oversampling inside of a buffer area around the project site. And this was really implemented to try to minimize model variability. So when we do a build scenario, you're going to use your project land use inputs as either replace or append. And then your no build scenario will not use your land use inputs, but it will match the sampling rate and buffer area to your build scenario. So that at the end of the day, you do have an apple and an apple to compare. And at this point, I'm going to go ahead and turn it over to Hannah Carson to talk a little bit more about the employment densities and the tool itself.
Great. Hi, my name is Hannah Carson. I am a senior analyst at RSG, and yeah, I'll go through some of the details of the sub-area enhancements. Starting with the employment densities, the first part of the enhancement was to update these for each land use type using existing data sets, which I've shown in the table. Most land use types use building or facility square footage to calculate a square foot per employee density. But for land use types whose usage goes beyond just building area, like golf courses, parks, and beaches and cemeteries, we used densities of acre per employee for those land use types. There was also a number of non-standard use calculations, such as enrollment per employee for schools, beds per employee for hospitals or group quarter facilities, seats for movie theaters, pumps for service stations, things like that. And all of these new employment densities serve as a static input for the automated land use converter. So on the next slide, the land use converter goes through a series of steps to update the model inputs for the sub area projects. And the first step is to check if there's a TAZ split. So a Python script does this check and updates necessary inputs, which are shown in the table. And then the Python script will also update the land use file with the new MGRA to TAZ correspondence and copy the network files to both the build and the no build scenarios. On the next slide. The second step of the land use converter is using client land use form shown here to update the land use file with the new employment, housing, hotel rooms, open space acres, and enrollment. The client will specify the project MGRA, land use code, and then the necessary unit types. Examples are square footage, number of beds, number of seats, or number of students. And if the number of employees is not specified for the project, then the employment densities are used to calculate the employment using the most reliable unit type that has been provided. And then households, hotels, parks, and enrollment are all updated based on their land use code and the associated unit type. So that's dwelling units for households, acres for parks, students for enrollment. So we tried to keep this all pretty self-contained and simple to use and simple to move around. It's just an Excel workbook. So on the next slide, this step also includes some interactive maps and tables which allow the user to visualize these land use updates. So the change in households and employment densities, and be able to see the difference in land use between the build and the no build. This is just a QA/QC measure for the user and the clients to ensure that the model is correctly representing the project. On the next slide. So the third step of the land use converter is generating the new population associated with the project. And the tool uses population sim software to update the population for the project MGRAs only. So this ensures that the population outside of the project is consistent with the no build. We use the existing population to build controls for the new population, and that ensures that this process is going to work for any model year. We control for household size, number of workers per household, household unit type, and population age groups. And there are two options for sampling. And the first default option is a geographic sampling around the project MGRAs. So the user will pass in a threshold for number of households and number of TAZs, and it searches outward from the project MGRA until both those thresholds are met. And then that serves as your sample from which the controls are built for the new population. So that option means that you expect the demographics of the project to look like the nearby neighborhood. And if that's not the case, then we have the option to specify a list of MGRAs from which to sample. So that allows you to control the demographic makeup a little more tightly according to the project. We've also included an option for affordable housing, and the only caveat is that you must pass in a list of MGRAs which you expect the affordable housing to kind of look like or mirror. Well, on the next slide. The last step of the land use converter is applying sampling rates to the population. So the idea is that we'll oversample the project area and to reduce the model variability and make the results more reliable. So the user can specify 2 buffer distances and 3 sampling rates. And these are applied from the project area. So this step also creates an interactive map to visualize these sampling areas for the build and the no build, and then you can see what you've captured in these and make sure this aligns with your expectations. After all these updates are made, the new land use and population files are copied to the scenario folders, and you're good to go. So on this slide, so after the land use converter has done its thing and you're ready to run the model, I'll just talk about one of the new features that we added, and that is the automation of the shadow pricing procedure. So previously, the user needed to manually edit the property file in order to execute the model steps for shadow pricing. But now in the MGUI, we have this option highlighted, skip shadow pricing, and that just automatically updates the property file with the appropriate corresponding options. So one less thing to remember. And with that, I'll pass it off to Kundo.
Thank you, Hannah. Hi, everyone. My name is Kundo Llano. I'm a transportation modeler at Sandag, working under Mike Calandra. So one of the other features of this ABM2+ sub-area enhancement tool is the ability to increase the number of select link or select zone queries. We are currently limited to a maximum of 3, and with this enhancement, we are able to add 2 more for a maximum of 5. The process includes expanding the size of the M database so that it has more space to accommodate more data. While this ability to increase the size of the M database has always existed, we had typically done this process after we had run the model, meaning the database was already filled with data, which makes it less efficient when trying to change the size of it, and hence it takes longer to do so. And so with this enhancement, this feature is brought to the forefront of the process by including it in the model setup. We now indicate at the beginning of the process how many select links we plan to run, and then the process will automatically resize if needed. The advantage of doing it this way is that we're now resizing an empty M database, allowing for a more efficient and therefore quicker process. Next slide, please. And so as part of the land use converter tool process, we tested multiple test scenarios. One of them was a hypothetical project, the Seaport Village redevelopment project. For this, we used a Seaport Village master plan that I found online, and we modified it for our needs, for our testing needs. Some of the hypothetical features include a project year of 2035, 350 multifamily households, 20% of which are assumed to be affordable, 1,600 employment, and 1,500 hotel rooms. And an important project evaluation metric here in the Service Bureau, or in the Service Bureau projects, is VMT, or vehicles miles traveled, especially with California Senate Bill 743, which requires VMT as the metric by which we assess the transportation impacts of the project. And here we can see VMT for no build and build of this hypothetical project for city center or downtown and the project site. It's broken up by resident VMT and employee VMT. We see that in general, enhancing the land use would reduce VMT a bit, both on the resident and employee side. Next slide, please. So in an effort to test all the components and features of the land use converter tool, we came up with 16 different test scenarios, one of which was the large-scale Seaport Village hypothetical project. So far, these tests have been very useful in smoothing out any issues, and it's been usually an iterative process where if we run into an error, we'll either investigate internally, we would reach out to RSG, they'll fix it, and then we proceed from there. In addition to checking that the software is working, we also want to use these tests to make sure that the end results make sense. So we have a number of evaluation processes in place, including a mode choice report, similar to what Mike Calandra spoke about earlier. We have a VMT report, and then we also have some regional summaries just to make sure that the sub-area enhancement do not illogically affect travel demand at the regional scale. And with that, I'll pass it back to Mike.
All right, thanks, Kundo. So one of the deliverables that we asked RSG to put together as part of this overall contract was a trip table data report. And in this case, it's going to give us both person and vehicle trips as derived from the 2016 base year scenario. And I think it's really, really important to note that, you know, this is a data set is intended to augment the ITE trip manual and the local San Diego traffic generators manual. It is not intended to replace, because at the end of the day, the bottom line is it's still modeled data. It's not observed data. If you're looking at ITE, either international or San Diego, that's all observed data. So that's really the big difference. But what this will do is, like I said, it'll augment, and it will hopefully help you understand, you know, your input versus what you could expect on the output. So this is just focused in on some of the land use codes where use of acres is applicable. So for example, golf courses and active parks. And here on the right, you see your corresponding vehicle and person trip rates per unit. A lot of actual thought went into this to try to derive these rates. RSG had to go through each MGRA and find MGRAs where this was essentially the only use. And then we could aggregate all of those trips in acres to come up with this kind of table. The point being is, if you had an MGRA with a golf course in it, and you also had a restaurant next door to it, that restaurant could potentially affect the trip rates that you're seeing here, because it's not all in the same MGRA. So really, by isolating land use codes where this is the only use in the MGRA is what I think really kind of makes this table, I think, going to be a good piece of information for people to use. Actually, in the same report, we also started looking at model variability. And to be honest with you, this is the motivation behind wanting to run build and no build land use scenarios. So at the end of the day, we can have an apple and an apple. So internally, we had done 10 different scenarios, base year scenarios, where the first 5, we essentially just set up the scenario and ran it 5 times in a row with the same random seed. And then we could look at the results. And then we did 5 more scenarios where we went in and we actually put in random seeds, so we could start looking at some of those differences. So from a like a region-wide perspective, looking at all of these, you know, we're getting like a 0.1% or 0.13% region-wide variation in VMT. The report itself does go into other metrics, including 743 VMT and mode choice. But one of the other things that I thought was really kind of telling on this variability report was looking at the submodel VMT. So now, you know, at the bottom, we have 84 million, which is about what you'd expect in a 2016 scenario. But now we have the ability to kind of look at it in terms of which submodel is producing this VMT. Now, the couple that I've highlighted here, the individual, that's, you know, the largest lion's share of VMT for any of these scenarios. If you've got 57 million individual VMT over 84 million, it's a large percent. So in this fixed random here, we're getting 0.08% variability, 0.06% for the total. And then corresponding, these numbers over here on the right is what it would be in the random seed. So it's, you know, your individual does go, your variability does go up, but it's still really, really, really small. So those, that variation report was actually also used to define thresholds. And thresholds are really of just essentially of people and employees. How many people do you need? How many employees do you need to make your mode choice and your VMT reports statistically significant, where you can have confidence to use them in planning studies or environmental documents? So RSG dug deep into some of those variabilities. And in particular, the selection of a threshold is based on judgment to select a threshold that provides a value of less than 10% for the mean, median, first and third quartiles, and the 95th percentile. And here you can see we have achieved it at 300 people. Now moving into the employees, we need to go a little bit further, and 500 was selected, even though the 95th percentile value did not actually reach that 10%, which is what we would like. We decided to go with the 500 figure due to the overall stability of the results that you see on this part of the table moving down, as well as now the lower number of records that we have in the MGRA count. But in particular, once you get to about here, all of these numbers stabilize and they start bouncing up and down. So that's, I think, one of the reasons why we just kind of figured we're going to go with 500 for the employees. So now that we're here, post-release, obviously we're going to be continuing testing. We're going to be going through a peer review in a couple of weeks. We're going to get started on the backlog of Service Bureau jobs. We're also going to be working with the local ITE subcommittee to streamline the request process. And then, you know, over the next probably 2 to 3 months, we're going to go ahead and start updating a lot of our data on the website, including the published data, model output data in TFIC, the 743 screening map, and then the jurisdictional mode choice reports that we just looked at. And as well, we'll also go ahead and make available many of these reports and deliverables that came out of the contract that we have with RSG. One thing I do want to cover is to talk about the parameters of the model in ABM 2+. And this is really kind of in the context of the 2021 regional plan, where you have the ability to look at either the vision network or a no-build network. But one of those two things doesn't go by itself. If you go with the vision network, you probably want to go ahead and use, and I'm not going to say probably, you definitely want to go ahead and use the SCS land use growth forecast. Conversely, if you use the no-build network, you want to use the baseline or the general plan land use growth forecast. The difference there in the land use is basically mobility hubs versus the general plan. And then if you go with vision and the SCS, the next parameter to consider are the policies, and that includes parking costs, transit fares, usage fee, and on and on and on. So really the point being is that if you're doing modeling beyond the year of 2025, these kinds of assumptions here will start to really affect your model results. So you want to kind of think about that ahead of time, and so you're understanding that what you're getting. And then getting back now to, you know, time and cost. I think at this point, with this new release that's coming out in a couple of weeks, we're going to get back to that 4 weeks per scenario. And that's probably going to include both build and no build on the land use side. we do anticipate time savings as we have larger jobs. Like if we have, a big general plan update, the first couple of scenarios are going to definitely be more aligned that 4-week timeline. But as you get further along in that application for a general plan update, the subsequent runs require less input changes, and therefore they can potentially have some time savings moving forward. Moving along into cost, this is something that really needs to be brought to everybody's attention. New hourly rates will be updated with the new fiscal year. The big thing to note here is that the current price sheet is based on the hourly rates from 2018, from fiscal year 2018, I believe. And so there is going to be a, somewhat significant increase in cost there. During the summer and into the fall, we're going to be going through and doing a cost analysis for running scenarios as well as producing the deliverables. And therefore, we'll expect to have a new price list to be developed, and we'll go to the executive director for approval. And I just got a note from Mr. Mike Duncan that I got the wrong executive director timing. But I thought that was fall 2022. But anyway, so look for that updated price list probably this.
Yeah. Mike, I can add a couple of notes on there, and then Mike, I'm not sure if he's on as a panelist and can speak, or if we could give him the ability to speak. We had it had been since Cheryl Mason was here, so it had been several years since we had done anything. So we were really not even meeting, or we're not making profit ever, but we were so far behind because when COVID and the pandemic hit. So we were able to finally get, after I think the last increase had been, Mike, I don't know if you can share, multiple years since we had updated it. So it has been approved by Hassan. I'm not sure if it's on our website or gone out to Service Bureau clients yet, but it is in effect. Mike, can you add any more?
Yeah. Yeah, we're basically the hourly rates are approved, and they're substantially higher because 2018 versus 2022. Plus the fact is probably everyone in the industry knows, modelers over that time period have become a lot more expensive modeling work. And so, yeah, it'll be substantial, substantially different in terms of the pricing. And in terms of the, when we have Service Bureau projects, Mike C typically does an analysis of the level of effort and uses that plus the hourly rates to build out a cost estimate for larger projects. We have some standard rates, which we do have, which we can use for smaller projects. And, so that's all essentially ready to go. And then, but yeah, we will see some differences in terms of pricing.
All right, thanks, Cindy and Mike. So here's how to get started. You can contact any one of the four of us really to get going, and we can, get your job logged and provide a time and cost estimate. At this point, we do have one more quick agenda item to go through for Wu, but just really quickly, Joaquin, did we have any questions on our chat that we want to try to cover?
I think we do, but I think before I'd like to go to Hamid Bahadori from the City of Oceanside. He had a question that he wanted to ask via audio.
Thank you, Joaquin, and thank you, Mike, for a great presentation. Can you hear me?
Yes.
Okay, as you know, we have been trying to update our circulation element, and we've been working on the previous model version of it, to put on hold, waiting for the new model to be available and all that. And Chen Ryan, our consultant, has been working with you and your staff about timing and all that. Just briefly, and you might have answered some of the questions in terms of maybe revised costs and all that, which you said is not going to be available until fall. But when realistically do you expect the model to be up and running and validated and reliable enough for a city like us? We are in the process of circulation element update, and we have scenarios that we need to run and all that. When do you realistically think you will be able to start entertaining requests for model runs for different scenarios from our consultant?
So that's a good question. Our release date right now is targeted for July 15th, and I think we're pretty confident we're going to make that. We will be able to get started maybe even a little bit ahead of that to work on some high level like model calibration reports and that kind of stuff. In particular for the city of Oceanside, we do already have an agreement with Chen Ryan, and we're already starting to work with them on getting some of the inputs in. So you'll actually be the first one out of the gate.
Yeah, thank you. Two quick questions. So that agreement will be grandfathered under the old rates, or we will be subject to new rates that are going to be released in fall?
Everything that's already been logged is going to be grandfathered under the old rates.
Okay, and my last question, you mentioned something about the sensitivities beyond 2025. How do you see that affecting build-out scenarios for cities who want to run the circulation element scenarios?
Well, that's where this slide is really important. And I believe that I've had this conversation with Fong, and we've kind of worked this kind of stuff out, whether we're going to be going down the path of using the vision and the sustainable community strategy. But really, these parameters are very consistent for the 2016 base year through 2025. So it doesn't really matter which path you go down to. But once you get beyond 2025, that's where these things really start to weigh in and can affect your model results.
Yeah, that's a little bit of technicality issue that we need to pick up with our consultant.
Yes.
Thank you. Thanks for your time. Thanks for great presentation. Appreciate it.
Thank you. Anything else, Joaquin?
We had a couple of questions. This first one is from Eric Rohr, and he also kind of cribbed the question with maybe if the response is a little bit too long, given our time constraint, that we could maybe take it offline. But we'll go ahead and ask it right now, which is, do the variability results mean that we should use the maps rather than running the model for less than 300 residents or 500 employees?
So Mike, let me put my thoughts in here. Okay, so you can still run a model with less than 300 residents, 500 employees. You know, we just want to be careful that it may not statistically reliable. In that case, you just have to use your caution, right? You know, so I mean, our recommendation is that to produce some really meaningful number, we recommend the threshold is 300, 500. It technically doesn't prevent you from running a project under 300, 500 threshold.
Use it at your own risk, that's for sure. We are literally out of time, so let's go ahead and we'll respond to questions offline so we can at least let Wu talk about the ABM road ahead.
All right, I'll be really quick. First, I want to thank everyone for, so be part of this important, conversation, because you're the most important stakeholders for our modeling group, right? You know, our model is not just for SANDAG, it's really for the entire community. So I think, thank you again for being part of this, our program, So as Mike and Joaquin both mentioned, that while we're working on, customizing ABM2+ for Search Bureau sub-area analysis, we have started the modeling work for 2025 RP. Why? Because a lot of work, so this chart shows the key model components and the timeline. It can clearly shows how much work needs to do to get there, okay? So largely speaking, there are two categories. We can divide the work into two categories. One are the kind of the core bare bone or fundamental components that need to be in place for the model to run. So we call internally, we call them 4 M's plus 1 TCOV add. The 4 M's are, the first one is cross-border model update, utilizing the most recent cross-border survey. So the border project is a very important part of the agency, not just SENDAC, but the entire region, right? So the good news is done, okay? So that's first M. The second M is rapid strategic model. You can consider this as enhanced sketch planning model, but it's more than just that. So we're hoping that we're going to use the rapid strategic model RSM in the initial RP planning stage for 2025. It's scheduled to be done by July next year. Okay, the very big heavy lifting is the TCAF update. So Ying is leading this effort, so that's another one. So the third M is the commercial vehicle model. That's very important. Why? Because last mile delivery is very fast changing technology. So a lot of, you like myself, I do a lot of online shopping and Amazon in the regular use of the Amazon services, right? So it has to be in a model for 2025 RP, So the third part, the last one, of course, the most comprehensive, important one is the entire update of the activity-based model. This time we're going to ABM3. The most important feature in this model is that I'm going to have a base year 2022 to represent the post-pandemic new normal condition, because ABM2 plus, given the time and data, we still have a base year 2016, so that's the first category. Okay, on top of that, we have some of the key auxiliary products we need to produce. First one is some off-model calculator, right? Some of the variables cannot be reflected in ABM. That's part of the off-model calculator. There's a benefit cost analysis to update. And then there's also ABM3 database and 2025 RP performance metric procedures. So, some of the products you use, right, relies on the ABM database. As the model evolves, the database also evolves, right? So like our own model, at the end, we're going to go through very rigorous expert peer review. We're going to invite national experts to review every single step of the model, in a very detailed way. So right now the timeline is by probably May 2024, ABM3 is going to be in production mode. So that's the first slide. Okay, next one, Mike. Okay, so the model always is very data hungry, demanding. Okay, so this slide shows the data need to go into the modeling piece. So again, let's just say there are 3 categories of the data. First is the survey data. That's established the travel behavior, all the math behind the model, right? So when parking survey, we're wrapping up, I can say this is probably the best parking survey I have ever done at SENDAC, So we have a household travel survey, which Grace is leading. I can say this is probably the best survey I've done so far. Not only that, but also we have reached the sampling plan. We achieved the sampling plan a lot earlier than we expected. So that's the travel survey. Commercial vehicle survey, we're going to start very soon. That's a very important part. So that's the survey, okay? The other hand, we observe data for model validation. How do I know our model performs okay? We have to compare the very different, various kind of observed data. For example, the traffic volume, right? So and the traffic count and transit register count. Caltrans public road VMT region wide. We need to match to that for base year, right? So in this time for the 2025 RP modeling, we plan to utilize the big data in a more enhanced way than before, because it's becoming more and more a bigger deal. So that's why we started the big data evaluation. And so that's the data part. So with that, I think, Mike, that's all I have. So yeah.
Okay, thanks, Wu. I see one question that came through the chat from Claudia is, what will the base year for the 2025 regional plan be? And I think you answered is 2022. Well, thank you for everybody for coming today. Wu, did you have something else to add?
So I saw a question on the ACS. A question, did that get answered?
Joaquin?
Hi, Wu. Hi, Mike. No, we didn't. So if you'd like to answer that via audio.
Yeah, so the travel model doesn't use ACS data directly, okay, or maybe a little bit, right? You know, so however, the data, ACS data matters to travel data. Why is that? Okay, the very important input to ABM are the synthetic population, right? You know, household and, you know, people, right? Their income, their gender, you know, so, right, you know, so their household size, whether they own a vehicle and how many they own, right? So those information are coming from, you know, so related to ACS. We have a forecasting team to produce those for us, utilizing ACS and some other data sources. But we don't use the ACS like the survey. It's not a direct input into the model, you know, so at least the travel model. If there's any direct connection between ACS and travel model, so we use the you know, the work purpose, like there in ACS, there is CTPP data set, you know, for travel models, for example, for work purpose, the mode share, you know, so we use those for model calibration and validation, you know, so so that'll be the answer to that.
All right, anything else come in? Probably a
I
good
don't
thing.
believe so, Mike. Nope.
Okay, probably a good thing since we're quite a bit over now. Just noting our next Transportation Model Forum right now is scheduled for December 14th. And with that, I wanted to say thank you to all of our guests and all of our panelists for presentations today. And with that, we are adjourned. Thank you so much, everybody.
Thank you.
Thank you.